As usual, this is a disclaimer. All shown ethical hacking and cybersecurity tips on this channel are for educational purpose only. Do not use any technique or method shown here on networks or machines that do not belong to you. Otherwise, you may expose yourself to legal actions.
Python is a high-level, general-purpose programming language known for its simple, readable syntax and versatility. It supports multiple programming paradigms, including procedural, object-oriented, and functional programming, and runs on all major operating systems without modification. Python's design emphasizes code readability and rapid development, making it accessible for both beginners and experienced developers. Python's straightforward, English-like syntax allows cybersecurity professionals to quickly write and understand scripts, even if they have limited programming experience. This is crucial in cybersecurity, where rapid response and adaptability are essential. Python boasts a vast ecosystem of libraries tailored for cybersecurity, such as Cypeee for network analysis, PyCrypto and cryptography for encryption requests, and Beautiful Soup for web scraping and intelligence gathering. Map via Python bindings for vulnerability scanning. These libraries empower security professionals to build custom tools for tasks like vulnerability detection, network scanning, malware analysis, and log analysis. Many cybersecurity tasks, such as log analysis, vulnerability scanning, and incident response, are repetitive and time-consuming. Python excels at automating these processes, reducing manual effort and minimizing the risk of human error. Python scripts run seamlessly on Windows, Linux, and macOS, allowing cybersecurity tools to be deployed across diverse environments without modification. A large, active community of developers and security experts continuously develops and maintains Python-based cybersecurity tools. This collaborative environment accelerates the sharing of knowledge and best practices, helping professionals stay ahead of evolving threats. Python is widely used in penetration testing and ethical hacking, writing exploits, automating attacks, network security scanning, monitoring, vulnerability analysis, malware analysis, detecting and dissecting malicious files, incident response, custom scripts for rapid response, threat detection, machine learning for anomaly detection. Let's go ahead and install Python on Windows, Linux, and macOS. I will run the lab in a virtual machine in VirtualBox. So I will right-click on an existing Windows machine and I will clone it. I will name it Python. Then I will click Start button to run the VM. I will enter my user password to login. I will open a web browser and type Python in the search bar, and click on the official link www.python.org. Then click on Download, and click on the yellow button. Please note, at the moment you are looking at this video, the screen on the web page may be different than the video. Open the downloaded installer. It is crucial and very important to tick both boxes at the bottom of the installer. Use admin privileges when installing py.x and add python.x to path. If you do not do it, you may face some issues later. Then click on Install Now and respond yes to the privilege escalation. Then click on Disable Path Length Limit. This is mandatory if you do not want to face execution issues later. Accept the privilege escalation, then click on Close button. To check Python installation, launch a Windows terminal. When a terminal opens, Type the command Python then press enter. This should have the following display. Press the Control key and the D letter key to exit Python. Type the command pip and press the enter key. This should produce some output. So far Python is successfully installed. Now navigate to VS Code to download it. Open it to install it, accept Terms of Service, and click on Next button. Click again on Next button. Tick those two boxes in the installer, and click on Install button. Finally, click on Finish button. Now navigate to Notepad++. Download it. Launch it, accept privilege escalation. Select your language and click on OK button, click on Next button. Then click on I agree button, click on Next button, click again on Next button. Click on Install button, wait for it to install, then click on Finish button. It is going to ask for an update. Click on Yes button and wait for it to update. Click on Yes button if it asks to close actual instance. Follow again the installation process. Now navigate to git-fork.com, download fork. Open the installer. Enter your name and email. Click on the folder Ions. In dialog box, click on the button New Folder and create the folder projects. Double-click on the folder projects and click on the button Select Folder. Click on the Finish button. Close all unused tabs, and now if you do not already have a GitHub account, we need to create one, otherwise just log in into your GitHub account. To create a GitHub account, type your email address and click Sign Up for GitHub button. Fill up the form, then click the Continue button. Resolve the CAPTCHA. Open your email box to check for the security code. Type it and click the Continue button. Log in with your freshly created user. If fork states for an update, then click on Restart and Update. Now we need to connect our GitHub account. To do this, go into Menu, File, then Accounts. Click on the plus button, click on the GitHub button, then Login button, enter your GitHub username, then click Sign In button. Follow GitHub connection process. If there is one, then click on Authorize Fork Dev. You are now connected. Click on Close button. We are done. Everything is set up. We are ready to use Python. To install Python on Linux, there are multiple ways to do it. I am going to show it on Ubuntu. Launch a terminal and type the command sudo apt update to update packages list. Type your user password when you are prompted to. Then type and follow all the commands I will be showing you in the terminal. Close and reopen the terminal to refresh the path. Now we will install VS Code with Snap. Python and VS Code under Ubuntu are ready. Alright, let's address now MacOS. Open Safari and type in the keyword Python. From the official website, click on the download link, then click on the yellow button to download the latest version of Python. Launch the downloaded installer and follow up the process by clicking Continue button as much as needed. Agree with terms of use and continue. Click on Install and type your user password. Python will then install. At the end of the installation, you will be prompted to move the installer to the trash bin. This choice is up to you. Open a terminal and type Python commands as shown to check if installation is correct. To quit Python, press the Control key or the Command key and the letter D. Now let's install VS Code as the Python IDE. Move the Visual Studio Code downloaded file to the Applications directory. And launch the file from the new location. Python and VS Code are ready to use on macOS. Let's start with the basics. Open a terminal and type Python or Python 3 or Python 3.x, where x stands for your Python version. Then write this simple code to display Hello World and press Enter. As you can see, it displays the message right away. To exit Python, simply type the command exit and press the Enter key. Now open VS Code. Then go in Menu File and click Open Folder. Select an empty folder where you want to save your code. Then if VS Code asks to trust the author, then trust the author as it is yourself. Read a file with name test.py and put the same code in it and save. VS Code might ask you if you want to install Python extension. I would recommend you to respond yes. Then from the console, navigate to the directory you created with the command cd. And finally type the command Python followed by the file name. You have just learned how to launch a Python script. Congratulations! Let's talk about indentation in Python. What is indentation? Indentation is required in Python to indicate which statements belong together, such as in loops, functions, and conditionals. Incorrect indentation will cause errors. Here are rules and best practices. Use 4 spaces per indentation level, recommended by PEP8. Do not mix tabs and spaces. Stick to spaces or tabs for consistency. The number of spaces or tabs must be consistent within a code block. Look at the example for demonstration. As you can see, VS Code has detected the indentation problem in the incorrect block. It has underlined it in red. Also, a red line shows up in the code preview at the right side of the IDE. The file name in the tab on top turned red with a number at its right. That is the number of errors detected in the code. You can add comments in Python to your code. Comments are used to explain code, make it more readable, or prevent code from executing during testing. To single-line comments, start with hashtag. Everything after hashtag on that line is ignored by Python. To multi-line comments, Python does not have a specific syntax for multi-line comments. You can use hashtag on each line. Alternatively, you can use a multi-line string triple quotes that is not assigned to a variable. It is mandatory to use comments in your code to explain it to yourself and to others in a context of a collaboration. You might ask yourself, why should you put comments for yourself as you have written the code? By experience, when you will write complex code, you will tend to forget what the code do after days or months. The comments will be here to remind you what is under the hood. Let's cover variables in Python. What is a variable? A variable is a symbolic name that refers to an object or value stored in memory. Variables let you store, reuse, and manipulate data in your code. To create variables, assign a value to a name using the operator. No declaration needed. Here are variable naming rules. Variable names can contain letters, numbers, and underscores, but cannot start with a number. Python is case-sensitive. myvar and myvar are different variables. We'll now explore 4 of the most essential data types you'll use in Python: strings, integers, floats, and Booleans. Understanding these data types is key to writing effective Python code. So let's dive in. Strings. A string is a sequence of characters used to represent text. In Python, you create a string by putting your text inside single quotes, double quotes, or even triple quotes for multi-line strings. Strings can contain letters, numbers, symbols, and even spaces. Look at the example displayed. Strings are perfect for storing names, messages, or any kind of textual data. Remember, anything inside quotes is treated as a string, even if it looks like a number. Integers. An integer is a whole number, which means it has no decimal point. Integers can be positive, negative, or 0. Look at the example displayed. Integers are used whenever you need to count things, work with whole numbers, or perform calculations that don't require fractions or decimals. Floats. A float is a number that includes a decimal point. Floats are used to represent real numbers, that is, numbers that can have a fractional part. Look at the example displayed. Whenever you need to work with measurements, averages, or any value that isn't a whole number, floats are your go-to data type. Booleans. A Boolean is a special data type that can only have one of 2 values, true or false. Booleans are great for making decisions in your code, such as checking conditions or controlling the flow of your program. Look at the example displayed. Booleans are often the result of comparisons, like 5 greater than 3, which would return true. In Python, true and false are actually treated as the numbers 1 and 0 when used in calculations, which can be handy in certain situations. To check data types, you can always check the type of any variable using the type function as the shown example. Choosing the right data type ensures your program works as expected. For example, you can add 2 integers, but trying to add a string to an integer will cause an error. Python also lets you convert between data types using functions like int, float, and str when you need to. We'll now learn how to interact with users using the input and print functions, the essential building blocks for any beginner Python program. Getting input with input function. The input function lets your program pause and wait for the user to type something on the keyboard. When you call input, Python displays an optional prompt message and waits for the user to enter a response. Once the user presses enter, the function returns what they typed as a string. Here's a simple example. When this line runs, the user will see "Please enter your name." After the user types their name and presses enter, whatever they entered gets stored in the variable name. Important note: no matter what the user types, even if it looks like a number, input always returns a string. If you want to use the input as a number, you'll need to convert it. This way, the input is converted from a string to an integer. Displaying output with print function. The print function is how Python sends output to the screen. You can use it to display text, numbers, variables, or even multiple items at once. Here is an example. The first line prints a simple message. The second line prints a message and the value of the variable name. By default, print separates multiple items with a space and ends the output with a new line. Customizing output. The print function. You can change how print function works using its optional parameters. SCP changes the separator between items and changes what's printed at the end. By default, it's a new line, but you can set it to anything, like a space or nothing at all, like the following example. Let's put it all together with a short interactive program. When you run this, the program will pause for the user to enter their name, then greet them using what they typed. Now we're diving into one of the most fundamental topics in Python programming: operators. Specifically, we'll cover 3 types: arithmetic operators, logical operators, and comparison operators. Whether you're a beginner or just need a refresher, this video will help you understand how these operators work and how you can use them in your Python projects. So let's get started. First up, arithmetic operators. These are the basic math symbols you probably already know, and they let you perform calculations in your code. The plus sign is for addition. The minus sign is for subtraction. The asterisk is for multiplication. The forward slash is for division. Double asterisks are used for exponentiation, raising a number to a power. And the percent sign gives you the remainder of a division, which is called the modulus operator. Let's see a quick example. As you can see, arithmetic operators are super straightforward and essential for any kind of calculation. Next, let's talk about comparison operators. These are used to compare 2 values and return either true or false. Double equal operator checks if 2 values are equal. Exclamation equal operator checks if they're not equal. Greater than operator checks if the left value is greater than the right. Lower than operator checks if it's less than. Greater or equal operator checks if it's greater than or equal to. Lower or equal operator checks if it's less than or equal to. Here's how they work in code. These operators are especially useful in conditions and loops, helping your program make decisions. Finally, let's look at logical operators. These allow you to combine multiple conditions. An operator returns true if both conditions are true. Our operator returns true if at least one condition is true. Not operator reverses the result. It returns true if the condition is false. Check out this example. Logical operators are powerful tools for controlling the flow of your program, especially when you have complex conditions. Now we're diving into one of the most fundamental concepts in programming: control flow. Specifically using if, elif, and else statements in Python. Control flow is all about deciding which lines of code get executed and when. In Python, this is primarily managed with conditional statements: if, elif, and else. These allow your program to make decisions and react differently depending on the situation. Let's dig about the if statement. Let's start with the simplest, the if statement. This checks a condition, and if that condition is true, executes a block of code. Here's a basic example. If the condition age greater or equal to 18 is true, Python prints you are an adult. If not, it skips the indented code. Let's be adding more choices. What if you want to check more than one condition? That's where elif comes in. delif stands for else if. It lets you test additional conditions if the previous ones weren't true. Here's how it works. In this example, Python checks each condition in order. If age is 16, the first condition is false, so it moves to the elif. Since age greater or equal to 13 is true, it prints you are a teenager. Only the first true conditions block is executed. Finally, the else statement is your catch-all. If none of the previous conditions are true, the code inside the else block runs. In this case, since number is 0, neither of the first two conditions are true. So Python prints 0, also as you noticed, using the input command. It is crucial to convert the return string input to integer, otherwise the program will crash with an error. Why use elif instead of multiple ifs? Using elif makes your code cleaner and avoids unnecessary checks. If you used multiple if statements, Python would check every condition. Even if one was already true, with elif, as soon as a true condition is found, Python skips the rest. Now we'll dive into the world of loops, the for loop, the while loop, and two important control statements: break and continue. Mastering these will help you write more efficient and readable code. Let's start with the for loop. A for loop in Python is used to iterate over a sequence that could be a list, a tuple, a dictionary, a set, or even a string, unlike some other languages. You don't need to set an index variable manually. Python's for loop handles that for you. For example, if you have a list of fruits in the following example, this code prints each fruit in the list one by one. You can also use a for loop to iterate over the characters in a string. Each letter is printed on its own line. Now, let's talk about the while loop. A while loop repeats a block of code as long as a certain condition is true. Here is an example. This prints the numbers 1, 2, and 3. The loop checks the condition before each iteration. So as soon as number is greater than 3, the loop stops. Be careful if you forget to update your condition variable, you could end up with an infinite loop. Next up, the break statement. Sometimes you want to exit a loop before it naturally finishes. That's where break comes in. Here is an example. Here, the loop stops as soon as it encounters banana, so only apple is printed. Break works the same way in both for and while loops. Now, let's look at the continue statement. Continue is used to skip the rest of the code in the current iteration and jump straight to the next one. Here is an example. This prints 0, 1, 2, and 4 but skips 3. Because when I is 3, the continue statement tells Python to skip the print statement and move to the next iteration. You can use continue in both for and while loops. Now we'll break down the 4 fundamental collection types in Python lists. Tuples, sets, and dictionaries. We'll cover how to create, access, and modify each one, with clear examples along the way. Let's dig lists. Lists are the most flexible built-in data structure in Python. They're ordered, changeable, and allow duplicate values. You create a list using square brackets like the following example. You can access elements by their index starting at 0. Modifying lists is easy. You can add items with append, insert them at a specific position with insert. Or extend the list with another list using extend. Removing items can be done with remove, pop, or del. Lists are perfect when you need an ordered mutable collection. Tuples are similar to lists, but they're immutable. One created, you can't change. Add or remove their elements directly. Tuples use parentheses. You can access elements just like lists. But if you try to change a value, Python will raise an error. If you need to modify a tuple, you must convert it to a list. Make your changes and convert it back. You can also concatenate tuples or add new items by creating a new tuple. This immutability makes tuples useful for fixed collections of items, like coordinates or ribbed color values. Sets are collections of unique, unordered elements. They're great for removing duplicates or performing mathematical set operations. Sets use curly braces. You can add elements with add or merge sets with update. To remove items, use remove, discard, or pop. Remember, since sets are unordered, you can't access elements by index. Dictionaries store data as key-value pairs. They're mutable and unordered, making them perfect for mapping relationships. You create dictionaries with curly braces and colons, access values by their key. Add or update entries by assigning a value to a key. Remove entries with del, pop, or popadem. Dictionaries are ideal for storing data that's best represented as pairs. Like user profiles are configuration settings. We have covered together the most basic concepts of Python. You can train on what we have seen. This is the end of the first part of the crash course. See you in the next video.
To help this channel, please subscribe, activate the bell, like, and share this video. Thank you for watching.